All right, a couple things we're going to talk about. Notes from last time. We're going to finish them. I think we just had a few slides left. Good morning. Notes from last time. You're going to need them. Also, we're probably going to start day 3 stuff. I don't know if we're going to finish it or not. If not, it's okay. But I know that next week it's going to be a crazy schedule being, well, we have Stinger on Monday. But besides Stinger, we will only meet on Thursday next week because of SOL testing. Oh, that's actually, oh, okay. Well, you're going to need that soon, Edwin. Don't lose that. That's a homework assignment. So we're going to finish Unit 8, Day 2 notes. There really isn't that much more we need to do. Okay, you also need that. That's a homework assignment as well. Don't lose that. Again, Unit 7 tests have been graded. Unit 8, Day 1 homework is due today. Yeah, that's the one. So, Unit 8, Day 1 is homework is due today. Unit 8, Day 2 homework. That's actually not due until not next Monday, but the following Monday. But as always, if you get your work finished earlier, you can always turn it in earlier. Because I think one of the goals on Monday, when we meet for Stinger, is to look over our homework assignments. That's what I would like for us to do on Monday, is to look over the Day 1, Day 2 homework. Because that would be a good idea. And then from there, and if need be, we could also answer questions on the Day 3 materials. Because again, we will only see each other for one regular class period next week. And that might be a day where our goal is look over Unit 8, Day 1, 2, and 3, like some of the most essential information from those 3 lessons. All right, questions before we start. Should be, now, I think we stopped from last time. I think we stopped, like if your angle starts somewhere that's not in the center, but if the ends are at the diameter or at the semicircle, then basically the angle that came from the semicircle was 90 degrees. And again, it just goes back to the regular rules about you go from arc to angle. You go from, let's say, arc to angle. I got your notes from last time. But it's angle's not at the center. That's why. All you do is take your arc, divide by 2, and then that's how you get your angle measure. So that's basically what's going on here. Since your arc, in this case, the arc is 180 degrees. So basically, we're not learning anything much more new. The arc was 180 because you had a semicircle. Divide by 2. Boom. You have a 90-degree angle measure. Again, arc is a semicircle. That's where we get the 180 degrees. So these are just little tidbits, facts. So I think that's where we stopped. So we had this problem right here. Your angle. Make your arc. So your angle from the semicircle. Semicircle 180, angle has to be 90. So that was basically the general goal from last time. Arc, divide by 2, you get your angle measure. Now, just to make sure, if it's angle measure, let's say I gave you an angle measure. What do we do to get to the arc? Do we divide or multiply by 2? Yeah, if we're going from angle to arc. Well, if we go from arc to angle, if you're going from angle to arc, then you multiply by 2. So, and I think that might be, so arc to angle, divide by 2. If it's angle to arc, so I'm just going to put this on the side right here. In fact, no, I don't want to put that there. Let me put that maybe on the next one. Nah, all right, well, let me put that back here. So, I'll just put it over here, so that's just for other purpose. Angle to arc multiplied by 2. And if my mouse ever works. So that's basically it. So arc to angle. Now remember, the angle cannot be at the center. But it's still inside the circle. Inside. All right. Okay, questions. So this is basically a touch-up from what we did last time. Again, you should have this. You don't need to do it. And then from the last slide, well, not the last slide, but I think the following problem was a similar problem. So make sure everybody has that. If you haven't done so already, I'll wait a moment. So basically, arc to angle, divide by 2. Angle to arc, multiply by 2. That's what you do. Again, your angle's not at the center. Now, let's say if the angle was at the center, which we'll talk about now, but if the angle was at the center, do we have to multiply or divide by anything? Or were the arc and angle the same if the angle was at the center? Anybody remember? All right. So if the arc and the angle were, let's say your angle's at the center, you kind of see it here. See that 180 degree, that diameter? That's a straight line angle. That matched up with this arc over here. Unlike here, this angle formed at the diameter. That's why we got the 90-degree angle. This is your straight line angle. If it's at the center, if your angle is at the center, angle and arc will be the same. So if angle's at center, then angle and arc are the same. Might just be. So that's just something. That might be something to think about. This is basically what we've been talking about the last couple of classes. Angle equals arc. Angle is at center. Angle's at center. All right, questions. And then the next problem, I think this is where we definitely stopped. This was an unrelated diagram, so don't worry about that. But I would focus for this particular example. I would just focus on this part right here. This is totally unrelated. Again, there's your angle. Endpoints were at the diameter. That's why. And you could kind of say, even if we didn't have this diameter, your semicircle's 180. So the angle that formed must be 90 degrees. And then if you solve that equation, 13x minus 1 equals 90, you should get x equals 7. Again, that's a try. You may get a test question like this, I don't know. But if that happens, you know exactly what to do. Semicircles, 180. Angle must be 90. And then you set this angle equal to 90. If it's an expression, you solve for the variable. All right, questions? All right, there's only a few more slides from the previous notes, and then we're going to start with today's new activity. Let's take attendance very quickly. All right, here we go. Okay, last thing I want to talk about. Anytime you have quadrilateral, now, I think this is one of the last problems from the 8-2 homework. Supplementary. Opposite angles. So basically, the two angles are going to cross. They add up to 180. That's really what's going on here. Add them up, 180. All right, questions. So that's basically what we have going on here. If you're quadrilateral of any type, it's inside the circle. Opposite angles add up to 180. But your inscribed angle rules are still in effect. So if you're given arc, divide by 2 to get your angle. You're given the angle, multiply by 2 to get your arc. So whatever this angle is here, you double it to get the arc. Whatever this entire arc is, but you got to be careful. It's going to be more than one part. Because remember, at every angle, it's going to form two parts of the overall arc, so do be careful. Because I might give you an arc, you give me that angle. But then you may have to add the two parts. All right, questions before we start. So there's only going to be a little bit that I'm really going to talk about from from this last part of 8.2. All right, here we go. Remember, opposite angles are supplementary. So basically, you just have to figure out these two angles, L and J, are opposite. You have to add up to 180. So something plus 92 gives us 180. Similarly, from angle M plus whatever angle K is, adds up to 180. So basically, we want, okay, to get angle J, angle L plus angle J add up to how many degrees? Angle L plus angle J must add up to how many degrees? 180. Now, do we know what angle J is? No. Do we know what angle L is? L. 92. To figure out 92 plus something.
Do 192 minus, 180 minus 92.
Yep.
And that would give us 88.
88. Very good. Go ahead. Question? Well, basically, 92 plus something has to equal 180 because L and J add up to 180, right? So we already have 92. We need to figure out how much more. So we subtract 180 minus 92. You got to subtract 92 on both sides. That's how we get the 88. So 88 is going to be the measure of angle J. Similarly, okay, M plus K has to add up angle M plus angle K, add up to 180. But how many degrees is angle M? 45. So it's.
So would you subtract by 45 again?
Yeah. So it'll be. So yeah. So if we subtract two numbers, what would we get? 135. So angle K is going to be 135 degrees. So yeah, 45 plus angle K is 180, so angle K has to be 135. Basically, supplementary. Add up to 180. So far, any questions? Any questions up to this point? Okay. Now, the next problem We're gonna have to work a little backwards. Well, we get first. Now, do we have to solve for the angles in order?
No.
No. So one of these angles, well, they gave us angle Y. So out of the three angles, three other angles, V, W, X, which one can we find first?
Y and W.
Y and W. Because you know that Y plus W has to add up to 180. Now, how many degrees is angle Y? Okay, so W, so what's the 129 going to represent? Which one? Good. That's what I wanted to hear. Very good, Valerie. Angle W is going to be 129. Good start. All right, now the other ones are going to be a little harder. But here's where we have to go back to the rules about circles, the sum of the arcs, 360, and all that stuff. So here's what we need to do. In our circle, we have a 101 and a 67. That's two of our arcs. However, in order to get the entire circle, which is 360 degrees, we need to figure out the remaining arc measure that's missing. But it's missing from Y all the way to W. So in our circle, grand total was how many degrees?
360.
Okay. How many degrees do we have so far with our circle?
129.
Circle. Don't worry. So the 129, that was,
51.
what's that?
51.
Okay.
51 and 67.
Um,
67.
All right. We're going to stop. Let's start again. So look at our circle. It's 360 degrees, correct? Now, two of our arcs measure 101. You do add those. So you have 168. Say it louder, Valerie. Okay, say that again. What did you do? That's what you do. Very good. To get the remaining arc that's over here, you have to take 360 minus, in this case, 168. The 168, that comes from up here, the 101 plus 67. See, and that's how we're starting to use, and I know, Alex, you said 168 as well, so I don't want to take credit away from you. I know you said that too, but that's exactly what we need to do. That's very good work. I'm impressed. So now we take the 360 minus 168. What's our, somebody said it, what's the remaining arc length?
Okay, it's 92.
192. All right, let me move this circle out of the way. So yeah, the remaining arc length from here all the way to here is 192. Now, let's talk about that 192. Let's look at, now you can look at either angle X or angle V, but, and either way we're going to get the same in the end. But since we have arc lengths, what do we have to divide by to get our angle measures? So this is going to be a little work, this last little bit. But notice how, if we look at angle V, let's look at angle V, everybody. Angle V. For which one? Exactly. It's going to be 192 divided by 2. Very good. Yeah, angle V is going to be 192 divided by 2, which is 96. Very good, Val. That's going to be 96 degrees. Now to get angle X, well, which angle is opposite angle X?
V.
V and X are opposites. So that means
180 minus 96.
180 minus 96. Very good.
And that's 84.
Exactly. Well done. And then the other way you could have done it, what's 168 divided by 2? Okay, so remember how we had the 101 and the 67 for the two arcs that were opposite angle X? If we divided 168 by 2, that's the other way you could have done that problem. Get the X, then the V. So there was more than one way you can get that done. And again, these are all these little rules. So these are little rules that we need to remember when we take care of these types of problems here. All right, anybody have any questions? If you're stuck somewhere, not sure, you gotta say something. Okay. And again, these rules, arc to angle, angle to arc, going to be in play. All right. Anybody have any questions on this problem here? Now, I think on your test, it's probably going to be more of those, well, your homework is basically, you're just finding the opposite angle. I think on day 2 homework, just find the opposite angle, you're done. You're not even going to be responsible from arc to angle for the last problem. I mean, there are other parts where, yeah, arc to angle, angle to arc. You're going to have to follow those rules. All right. I think we're going to do I'm going to look at the last couple. I don't think we're going to do all of them. Actually, this one we could do. All right. We're just going to do this one final problem here. And then I think we're going to go on with So the very last two slides, I would not even bother. I'm not even gonna ask you to do it for homework. I don't think you're gonna get them on a quiz or a test, so I'm not even gonna bother. So we're just gonna talk about this last problem. So this question, angle E and angle G, what is the relationship between those two angles? Who could tell us? Angle E and angle G, what would be their relationship? Too far. Yeah, so go back to the other page, previous page.
So I think what we want is 68 plus 9x minus 5 equals 180.
That's what we want for this one. Good. They're going to add up to 180.
We're solving for the x, right?
In the end, you're going to solve for the x. Yup. It's going to be 68. Good job, Catherine. It's 9x minus 5. And yes, Andy, you are 100% correct. We're going to solve for the x. Remember that.
So first we would add 68 and 5.
So 68 minus 5. You're going to combine the two terms.
68 minus 5.
Yup. You have to combine the two since they're on the same side. Say it again.
63.
So in the end, the 68 plus 9x minus 5 is going to become 9x, or we can say 63 plus 9x, that's fine. Because here we combine like terms. So first, I gotta say, well, I forgot to mention, angle E plus angle G is 180.
So then it's minus 63 on both sides.
Now we're going to do the minus 60. Say again. Okay. So minus 63 because we have to, so after we combine terms,
So then it comes down to 117.
so then we're going to have 9x is 117. Good.
So then you divide them both by 9.
Divide by 9.
And in the end, you get x equals 13.
13. Very good. I know somebody else. So a couple of you said 13. That's right. Again, it's all about that relationship. Now, again, some of you on your test made the mistake of adding 5. So 68 and negative 5, and you made that 73 plus 9x. Here, gotta combine alike terms. That's what you need to do here. Okay, any questions? So the goal is the opposite angles add up to 180. Combine your like terms if need be, and then solve your variable. That's going to be it for Unit 2, because the last two problems I'm not going to have you do. I mean, you could try them. I mean, I'll just give you a hint. This one, but I'm not going to really go over it. So basically, you'd have to do 360 minus 135 minus 91. And then I don't know, whatever number you get for that. Somebody just try that real quick. 360 minus 135 minus 91. $134. And then you'd have to divide 134 by 2. It's basically, if you're interested in doing these, so then this would be 67 degrees. So then your equation would be 15x minus 23 equals 67. And again, I think you get x6. But again, you don't have, I'm not going to have you do it. If you're interested in trying it, you can. But I don't think I'm going to make it this difficult. So I'll let you look at it on your own. You're not even going to be required to do it. It's just, okay, how did he get all this? And then so on. Then for this last one, basically it's going to be 50 and 96. 146 divided by 2. This is going to be 73. Again, divide by 2. And then your last part, 12x minus 25. 73 equals 180. But I'm not going to make, you're not going to get something like that on your test. So again, don't worry about it. If you're interested in trying the problem, be my guest. But again, I'm not going to have you, you're not going to be required to do it. Yeah, I think the value is going to be 11. Again, no worries. You're not required to do it. Okay? All right. So these last two, you're not responsible. We're just going to move on. Okay, questions before we move on to the new packet, which it's going to be a graded note activity. I don't know if we're going to get the whole thing. If we don't, no worries. All right? This is going to be a graded note activity. Guess we'll have Joshua, please. Yeah. Okay. So, I don't know if I gave you one or two. All right. Okay. All right, I'll look at this. Thank you, Howard. And then with A2, Howard, with A2, if there's any mistakes, I'll let you know. You'll have an opportunity to correct because we just finished covering everything today. But if everything looks good, then you're going to get full credit, all right? Thank you so much. Thank you for being responsible. I like that. And it's just being in general, being responsible. It's like getting your work done on time or even before on time. Hey, that's awesome. Being proactive. That's great. I like that. Okay? Keep up the good work. All right, let's talk about this one. So what's going to happen here? Arc, angle measures, intersecting chord, secants, tangents. A lot of the rules are going to be the same, but yet there's going to be some new ones. Now, here's what's going to happen. Basically, I'm going to tell you right now, don't even worry about this first slide. You can if you want. Basically, your goal is if your chords do not meet at the center, basically, their angle measure is going to be the result of the average of your arcs. So the average of the two arcs gets your angle measure. Or similarly, I mean, for the most part, you're going to get an arc, maybe both arcs, or an arc and an angle measure. Now, what they might do, which I don't think they will, they might just give you the angle measure here, and that, but you're going to have at least one of the two arcs. Also, do not forget the other thing. When you have your two pairs, your linear pair of angles, what is the sum of a linear pair of angles? The linear pair must always add up to how many degrees? Form a straight line, that means they add up to 180 degrees. So these are really, I think the next slide is probably even a simpler way to say it. But basically, it's all about, you're going to take the average of your two arcs and your line. Angle 1, angle 2 add up to 180. Also, remember, whenever we have intersecting lines, our angles going across are congruent because we also have, begins with a V. Anybody remember the word? Begins with a V with opposite angles? Huh? Close. Well, you might have said it. Vertical angles, very good. Because you're going to see that more in this next slide right here. This might be a little better picture. So we have our little drawing here. Basically, whenever you have your angle A, it's basically the average of your two angles. Now, also remember, your angle A is going to be congruent to this angle right here. These two angles, as Alex said, we got opposites. So angle A could also be right here. Or similarly, you're going to have angle B. Again, you got vertical angles. So just to let you know, angle B up, down, angle A going across. Again, angle A plus angle B will always add up to 180 degrees. So again, the arcs that are across from the angle intersection, you take them, take the average, that you're going to get your angle measure. All right? That's basically the goal here. And don't forget, the sum of all four of your arcs must always add up to, because it's a circle. Very good. So I think this diagram might be the easiest for us when we deal with these types of problems that we're going to be dealing with today. Now, again, I don't know if we're going to cover everything. If we don't, that's all right. Okay, questions before we start today? All right, here we go. Okay, let's look at what we have. Well, let's also find out, well, first off, angle AED. So get your highlighters, get your markers, get something so you can identify what you're trying to find. Because also, on your test, if you need to use a highlighter or colored pencil, never be afraid to ask. Say, hey, Mr. Connors, can I use a highlighter or a colored pencil? If that's going to help you identify your angles your arcs, what have you, I don't mind. You are more than welcome to do that. You're always welcome to use colored pencils, to use highlighters. So I think that might be an activity for us going forward. All right, so let's look at this. Angle AED. Well, where is angle AED? Where do we start? What letter? Where do we start for this problem? Okay, that's the arc, but but we're looking for the angle. So, where's our starting point? A.
E, D.
But where do I go to get to E? Down, right?
Down.
Okay.
And left.
So that's our angle we're trying to find. Now, what are we given? Angles or arcs? Okay, we're given arcs. How many?
2.
2 arcs. What are the measures of the 2 arcs?
45.
45. Now, what should we do with the 45 and the 109?
Put together.
Add them up. 45, 109.
154.
So add them up. 45 plus 109 is 154. So is that one arc or the sum of the 2 arcs?
Some of the 2.
That's the sum of the 2 arcs. Good. That's the sum of the 2 arcs. Now, okay, here's what we're going to do next. Sum of the 2 arcs gives us 154. Now, after that, we will do the following. Now, if you want the angle, let's go back. So if we're looking for the angle, right? So we got the sum of the 2 arcs. So sum of the 2 arcs is going to be 2 times that angle, right?
Yeah.
Two times the angle AED. So, what can we do to find angle AED? So it's 2 times angle AED is going to give us 154. So think about it like a variable. Well, what's our variable? What can we always use for a variable? Or a missing value? We can use x. There's our x right here. So let's change angle AED to an x. So basically, it's 2 times x. That gave us 154.
Okay.
So AED, we're going to make x. Always for an unknown, make it an x.
2 times x equals 154. So we have to divide 154 to find x, right?
Divide 154 by what to get it?
2.
Yep. So we're going to set angle AED.
And that gives us 77.
Mm-hmm. So angle AED, we're going to make it x. Yep. All right, so we'll just make sure. I'm going to take this rule over here. Oh, it's already... All right, let me rewrite that then. Hold on, let me rewrite this. Not by much. I mean, we're not gonna do too much writing. I just want everybody to see where we're getting all our values. So remember, 2 times our angle equals sum of the 2 arcs. Which in this case, the sum of the 2 arcs was 154. Actually, I don't need that. So this is more, the words are more like a narration. So basically, 2 times the angle is the sum of the 2 opposite arcs, I should say. Sorry, I forgot to add that word. So basically what's going to happen is you have to find your angle, find your opposite arcs. Once you do that, then you're going to be in a position you could solve for this problem. So you identify your angle and the opposite arcs. So that's our goal. So what do we need to identify? So the goal, identify the following. Angle, opposite arcs. Okay, any questions? Anybody have any questions on that? So you find your angle, find the opposite arcs. All right? Not too bad, right? Remember, your opposite arcs are going to be over here and over here. That's your opposite arc. So you can cross the center or you go to the end of the circle. Don't cross that line, don't cross that line. You can go to the end, or since this angle is the same as this angle, go to this end. All right? So that's why you could say 2 times the angle is the sum of the 2 opposite arcs. That's where you get your opposite arcs. Identify your angle, look across. Look across. Don't cross the chord line. You can cross the center. The angle measures are the same. You can look across here, look across there. All right, any questions? So we're going to do that for the next couple problems. You're going to either get the angle or the opposite arcs, and then we need to figure out what's missing. All right? Not too bad, right? We can do this. Yeah? Annalyn, you got it? Any questions? Edwin, Joshua, Andy, you good? Zoe, good? Alex, Catherine, Valerie, good to go? All right. And again, more practice. So basically, and we'll probably do a little more of these next week. But it's basically, you're not going to get something too much more than this. Or you might get something a little, like, you might get the angle measured, but then I say, find the linear pair. That might be the furthest we go. All right, let's look at this. So look at the next one. Okay, now we have to find two angles. Let's look at what we have. So angle X, WZ, that's the first one. And then is Y, WX. Everybody see how I'm highlighting the two angles there? I'm going to highlight this a little different. It's that one. This one. All right. So, first question. What's given to us? What's given to us, angles or arcs? What's given here? If we look at our diagram.
Arcs.
Okay, we're given arcs. How many?
2.
2 arcs. That's even better.
43 and 81.
Okay.
So we have to add them up.
All right, so let's get our setup. So to get the angle, so which angle should we mark first? Should we mark the one that I highlighted in yellow or the one that I highlighted in blue? Huh? Yeah. That's the one we don't know. That's the one we can get first. You can get this one. So highlight, so indicate. So basically what's going to happen is these two arcs, it's going to be the sum of the two arcs. Arcs equals, we'll say 2 times opposite angle. But we made the opposite angle x. So what were the sum? What 2 arcs are we taking again? What 2 numbers? 43. It's 81. Now 2 times. Well, do we know what the measure of the opposite angle is yet? So we mark it as an x. Now, can we add 43 plus 81? What do we get? 124, that's right. So what you need to do is, what I would do, in fact, I think it might be easier. Anytime you get the arc, draw a line towards the opposite angle. That's going to tell you which angle we need. And vice versa, if you're getting the angle, draw it out to the arc. So 43 plus 81, 124, equals 2 times x. Now, how do we get x? Put it over, divide by 2. So 62. Now 62 is which angle? It's the x. But is it the yellow angle, which is XWZ? Okay, so it's going to be this angle right here. All right, I see where you got that. So you're going to have the 62 here. This is 62. And you're right, Catherine. This other angle right here is also 62 degrees. So I'm just going to draw an arrow right here. And I like your thinking. The two angles are congruent. So label your angle. Now,
We can get the other two angles.
we can. How do we get the other two angles?
180 minus 6.
Very good. That's exactly how you get that other angle. 180 minus 62.
That's 118.
That's right. Well done. And this angle will be 180 minus 62. That's really good work. So some of these problems might be piece by piece. So what's going to happen, the extent might be identify your arcs or angles, and do whatever you need, find the other. So basically what it's going to be, you get your two arcs, add them up, is that equal 2 times the angle measure. And sometimes you might have the angle measure, but you might need to find one of your arcs, which I think is going to be for one of the next problems. And then don't forget, once you have an angle measure, you get the other angle, the linear pair, by subtracting your first angle measure from 180. That's how we get the second angle measure. So again, the basic new rule is this rule right here. That's our new rule. Sum of your two opposite arcs, and I should say 2 times the opposite angles. So I forgot to write opposite up here. So remember, once you get your angle, identify that arc, or vice versa. All right, questions? And I think we have another one that's going to be just like this. Okay, any questions before we move on? Let's see what we have here. Oh, okay. This one's going to be a little different. And we're kind of going the other way. Okay, on the measure of arc LK. So what are we looking for in this case? An angle measure or an arc measure? So in this case, we're looking for this arc right here. Now, we do know a couple things. So this might be an idea where, for your sum of your two arcs, I would label it as arc 1 plus arc 2. So sum of the two arcs, 2 times your angle measure. The reason being, we know that this 62 right here is congruent to which other angle?
The J and M.
Between J and M, you're going to have a 62 right here as well. Now, how do you want to label your arcs? So you have your angles. JM. Okay, so is that going to be arc 1 or arc 2?
Arc 2.
Okay, we can make that arc 2. That's fine. So we can make arc K LK arc 1. So let's figure it. Well, do we know what arc 1 is yet? So how can we nickname it? Okay, that's fine. Arc 1. So, and I should just specify LK will make it arc 1. JM will make arc 2. So LK, we said we don't know it yet. You can. You're going to get. Say again? Okay, so then I know where you got the 124. Because if you multiply your angle measure, 62 degrees by 2, that's how you get your 124. All right, I'll give you that one, Valerie. Good job.
Plus 74.
So x plus 74 is going to be 124. Yup. Good. And then can we solve for x?
Yeah.
Yeah, you can.
Since both would equal 180, 180 minus 74.
Not 180 minus 74. Remember,
3.
don't do that. All you're doing is just, because remember, the average of these two arcs will be 62 degrees. So that's why we have to identify our two arcs that are opposite the angle. So all we're doing in this case to get this other arc. So after you double your angle measure, minus 74, that's all you do. It's going to be 124 minus 74. Yep. So arc LK is going to be 50 degrees. And you want to know one other trick? Here's another trick. If we want to go from 74 to 62, well, basically, if you do it it's like, if you go 74 minus 12, you get 62. Then what you could do is 62 minus 12 again. That's how you can get you 50. That might be another way to do it. It's not a safe way, but that could be another way. It's basically or vice versa. Let's say you figure out, okay, 50 plus something is 62. Then I add 62 plus 12 to get 74. So that might be another way to think about it. In fact, we might try that for the next. I don't know if we can do it for the next one or not. Let me see. Okay, so give everybody a moment. Look at this problem. Anybody have any questions on this problem here? But that might be something to think about as well. We can figure out, oh, 62 plus something gives me 74. But then what do I have to add what number do I add 12 to get 62? So that might be another idea to think about. So I'm just throwing ideas out there that might be easiest for you. Like, let's try next one real quick. All right, here's what's going on. I don't think I'm going to give you this one on the test, but I have an idea. We can make this happen real quick. We're looking for this arc QT, right? Do we know what QT is off the top of our heads? No. But we do know something. Okay, well, we're going to work with the 79 because do we have opposite arc measures to the 79? No. But do we know the measurement of this angle? You know the measurement of that angle. Nope. No, we're not going to do halves. Because the reason why we can't do halves is because the opposite arcs are going to be different. So we have to do something else. Okay, look at this line real quick. What does it form? This line right here forms a. So 79 plus something must give us how much? Remember, it forms a straight line. So a straight line is 180. That angle is going to be 101. 180 minus 79 is 101. Now, here's what I want us to do. 95 plus what gave us 101? What number plus 95 gives us 101? 101. Okay, 95 plus 6 is 101. All right. Now, if this angle's 101, then how much is this angle directly across?
101 too.
That's also 101. So if you want a real quick, cheap way to figure this out, see this plus 6? Oops. See this plus 6 up here? To go from 95 plus 6, you get 101. Keep your 101.
It's also the same with 79 too.
Well, be a little different because we don't know the arc measures here. But since we know this arc measure, the angle measure must be halfway, exactly halfway between lowest measure and the highest measure. So if we start at 95, we have to add 6 to get to 101, then we also have to add 6 to this other 101 to get to our final arc measure, which, well, what's 101 plus 6?
107.
107. So if you want it the quickest way, that might be the quickest way to do it. Or vice versa. If you went from bigger down to the small, you go 107 minus 6, you get 101. And then 101 minus 6 gives you 95. That might be another way to do it. So if you go from small to bigger, add. If you're going from bigger to smaller, subtract. And then basically you do a rinse and repeat deal. So that might be something to think about. All right, questions? And again, I know we're not going to complete all of these notes, so we'll probably be looking at look at some other information. All right. Real quick, I think for the last few minutes, I just want to talk about a couple of things. And then more than likely, I think we might talk a little bit about this on Stinger, but we're definitely going to review all of this on next Thursday when we meet for a full class.
We're gonna stop here.
The only thing I want to mention for the next couple slides, I think the next next couple slides we can knock out real quick. All right, basically, here's what's happening. Again, you're kind of going back to where you were before. And if you have the angle, multiply by 2 to get to the arc. So this is again, but it has to be this form. Like your angle has to be on the edge of the circle. So basically, you're back to angle to arc, but it has to be, but it can be of this type. So angle times 2 gives you the arc, or arc divided by 2 gives you the angle. But that's only if your circle touches the point where the two angles meet. So basically, you're back to angle divided by 2. I mean, multiply by 2 to get the arc. Arc divided by 2, you get to the angle. That's what you have going on here. But do know, your two angles have to add up to 180. Angle 1 plus angle 2 equals 180. That's always and forever. All right? And the sum of the smaller arc and a bigger arc add up to 360. So small arc plus big arc. So those are really the rules you need to know. And again, it's a lot of this is stuff we've already talked about. So I'll give you a moment to copy that real quick, but all these rules in the end are going to kind of make sense, especially the last two rules. You know about angle 1 plus angle 2 is 180. Small arc plus big arc is 360. That's always going to be the case. Because remember, the two angles form a linear pair. And then the other part, that's just the circle. Okay, questions? All right. Okay. We'll talk about a couple little things and then we're going to wrap it up. All right. So we'll just do one. Okay. I know what I did. All right. Here we go. DBA, DBC. So first we're trying to find angle DBA. But what's given to us? What was given to us? What are we given here? An arc or an angle? All right, what was given to us? Out of everything that's given to us, what's the one thing that was totally given to us? Were we given an arc or an angle? Look at our diagram. 192, that's an arc. So we need an angle. Well, what do we do with the arc? Given 192 degrees for the arc.
Then there's only one other arc, so 3, right?
Okay, well, what you thinking? I want to talk. All right, where are you going with this?
360 minus 192 to get the other side.
Okay, you can do that. I'm good with that. See, that's thinking. 360 minus 192. That is very good thinking. You can do that. I like that move. What do we get?
168.
Okay, 168. Ladies and gentlemen, that's very good thinking. Catherine just demonstrated super good thinking. All right, so now, can we find our angle measurements?
Yeah, probably.
How about definitely? But you're right, you can. So if we want this first angle, DBA, which number are we going to divide by 2? Is it the 192 or the 168?
192.
192 divided by 2, yes. Very good.
That's 96.
Yep, 192 divided by 2. That's 96 degrees. Good. So we got a 96. Now, given everything we know, there's more than one way we can get to angle DBC. You got 2 options. So, what could we do to get angle DBC? You have two really good options.
We could divide 168 too, right?
Yeah, that's one option. Divide 168 by 2. Because here's your 168.
Also, since the line forms a 180 degrees, you can do 180 minus 96.
That's the other way. Excellent thinking. Again, that's called using the information. So in the end, yep, you had 2 options. 168 divided by 2. That gives you 84. And then, or 180 minus 96. Excellent. All right. Now, I'm going to do a quick sum up. Now, definitely bring these notes back next time. But here's a couple quick things. Well, for slide 20 is going to be very similar to 19. Or problem 6 is very similar to problem 5. Basically, you can do the same thing. You can subtract 180 minus 151, and then get your arcs by multiplying by 2. So angle times 2 is arc. So that is your hint. And you can do that both here and here. Or you get your first big arc and then subtract from 360 to get the small arc. All right. Then the only other thing I wanted to talk about, I think we're going to definitely talk about next time. I don't know if we're going to do it during Stinger. These exterior intersections. Basically, all you're doing is taking your big arc, the larger arc, minus smaller arc, and divide by 2. We'll definitely go into detail next time regarding these types of diagrams, but it's basically the same thing. Larger, minus smaller, divide by 2, done. That's going to be your setup for all the remaining types of problems. So definitely bring We may, I don't know if we're gonna do it during Stinger or not. But definitely, I know we don't meet again till next Thursday, that's why I might just bring this up for a few minutes on Monday's class, because technically we started talking about it. Basically, larger arc minus smaller arc, divide by 2. But we'll see who's here during Stinger next, because I know some of you have SOLs. So real quick, I just need to know here